Alright, so I'm super irritated right now because I already recorded half of the paper, but I forgot to scoot it up so that y'all could actually see what I was doing here, and I can't figure out how to go back and edit the other one. So I get to do it again. Luckily, you only have to listen to it once, even though I have to say it twice. So I'm going to start back over. Today's our first day for Chapter 4, and I forgot to write Chapter 4 here on the notes, so maybe you want to just tell yourself Chapter 4. We are talking about scale models. Today and on Monday we're doing scale models. A scale model is something we really deal with all the time. A scale model is a map. I have a globe in my room. That's a scale model of the Earth. I know that you said you're into fashion, so whatever you design on a piece of paper, that's really a scale model of what you would create in real life. There's lots of different ways we use scale models, we just don't really think about it. So what exactly is a scale model? A very mathematical way of saying it is a proportional, there's that word we've been using a lot, a proportional copy. So it's the same exact thing, it's only smaller or bigger. That's what proportional means. It's the same, just a different size. And it could, like I said, either be reduced or enlarged from its original size. And here's an example of a good thing about using the video is that y'all can pause this and y'all can fill this out in your notes and then press play whenever you're ready for the next part. So next, to create scale models, we've got map makers. There's just very few examples. Map makers. We've got architects and engineers. Okay, so if a building is going to be built, they're going to make a model first to make sure that it doesn't tip over. They're going to build a model, they're going to put a fan next to it, they're going to spray it with a water hose, they're going to do everything they can to make sure that when they build the real thing, it's not going to fall down. Another example would be an airplane. They're going to build a model and before they make the actual thing, because that's going to be real expensive if they build something and then it falls apart. An interior designer creates a scale model whenever they write out or draw out the floor plan, and then they say, okay, well here's the door, so here's the couch and that'll fit, and here's the table. So they have to make sure everything's going to fit and be functional before they actually buy everything and decorate. Now why do we use scale models? Well, for example, so many people fly to Paris, France every year, and a lot of them want to get a little souvenir of the Eiffel Tower. So it's just about this big. Obviously the Eiffel Tower is much bigger, but they've got a scale model of the Eiffel Tower. And then car companies, they're going to make a toy car, like a toy BMW, a toy Mercedes, remote control cars. Those are all scale models, just trying to get their name out there. So souvenirs and toys. We also need a map to follow directions. So a map is a scale model of the road system. That's very important. We're all going to be following directions forever until, I guess, cars drive themselves and we don't have to worry about it. And then, like we said about the buildings and the planes and everything, we need to test performance. So is it actually going to work when we build the real thing? Test performance while saving money. So these are all key reasons why we use scale models. But of course there's tons of reasons why, and there's tons of different creators and examples. Here's just a couple. Alright, now to get the actual stuff that we're doing, let's write down here, we got 4 examples. We're going to calculate the missing value, and we're going to use proportions. Yay, proportions, to make sure you match the unit. So proportions is whenever I have one fraction equal to another, I cross multiply, and then I find what the variable equals. That's what we've been doing for about a month now, it feels like. So number one, the scale of the picture shown is 1 centimeter, represents 2.5 inches. Maybe y'all remember that I used to box this and say 1 ratio. These two numbers are together. I need to show them as 1 ratio. We're going to find the actual height of the cup in inches. The cup on the paper is 2 centimeters. Obviously, I'm not drinking coffee from something that's tiny. We want to know what the actual height is. So I've got 1 ratio, 1 centimeter is equal to 2.5 inches. And if you want below it, you can write, hey, this right here is the scale. You don't have to write that, it's just an option. This is equal to 2 centimeters, and I'm trying to figure out how tall it is in inches. So I'll put my variable there. I think someone's about to come vacuum, so let me figure out how to pause it real quick. Here's the pause button. Oh no, there's no pause button. There it is. Okay, maybe they're not coming in yet. I'll have to pause it again in a second. Alright, so at this point we would cross multiply. So I would do 1 centimeter times x inches, 2.5 inches times 2 centimeters. So 1 times x is 1x. 2 times 2.5, we'll do it over here. And that equals 5. So you get rid of multiplying by 1, I'll divide by 1. And x is equal to 5 inches. So the real cup is 5 inches tall instead of 2 centimeters. We've got 5 inches. That is our first example. Example number 2, I'm going to scoot it up this time so I don't have to redo the video for a third time. The city of Giles would like to install new flagpoles that are each 36 feet tall. The scale of the model is 1 inch is equal to 12 feet. These two numbers are together. I'm going to write 1 ratio here. How tall are the flagpoles in the model in inches?